Hey guys, today we're going to be talking about slope, distance, and the midpoint formula. So, quick review of some of these things because these should be topics that we're recalling from Algebra 1. So, first thing to start off, what is slope? Slope of a line is defined as the rise divided by the run from one point to another on the line. We can also think of slope as the change in y values divided by the change in x values. We use m to represent slope. Now, you guys all know what slope is. This is just the proper math definition, but slope of a line is, rise or run. We're trying to figure out how is that line either rising or falling and at what rate. It is a rate of change for a line. So if we want to determine the slope, like our first couple of examples down here, if we want to determine our slope, what we're essentially going to be doing is trying to figure out what's the rate of change between these 2 points and the line containing them. So our slope formula is we want to find the change in y over the change in x. So we can do y2 minus y1. So y2 minus y1 over x2 minus x1. Be aware of those double negatives. Sometimes people forget those double negatives. That's where it ends up some errors in these type of examples. So simplifying this problem, we see negative 5 on top and 13 on the bottom. Again, that double negative there. So the slope of this line is negative 5 over 13. This would indicate that this line, and we'll talk about it a little bit later on because there's a negative slope, looks like this, and we'll call it falling. But we'll talk about that a little bit more in the next page. Now, I have 2 examples for you to try finding the slope. Again, by all means, you guys can pause the video at any time to try to answer it ahead of me. I'll do A, and then I'll leave B as an option for you guys to practice on your own. So we want to try A to find the slope. M is equal to y2 minus y1. Again, y2 minus y1 over x2 minus x1. When I say x2 or x1 or y2 and y1, I'm just referring to the second y coordinate or the second x coordinate or the first y coordinate or x coordinate. In fact, you can actually find slope. It doesn't have to be y2 minus y1. It doesn't have to be the same order. You just have to be consistent. So if I choose this point to be first in my subtraction, it's going to be first in both lines of subtraction. But we could theoretically choose this point to be first in subtraction as well. Now simplifying, we see we have 5 over negative 14. And that is our slope of that example A. I'll leave B as an option for you guys to practice. Now, I will flip it like this. There are 4 types of slope, right, in terms of linear slope. We have positive slope, meaning the line is rising from left to right. Negative slope, the line is falling. Zero slope is an example when we have a horizontal line. And when we have a vertical line, we call that slope undefined. Now, positive, we call it rising because, again, we always read just like any book, right? We're going from left to right. This is going up. It's like a plane taking off. This is going down. It's like a plane descending to land. Zero slope means there's just no change. It's like walking on a flat surface. If you think about slope being how steep something is, this is like walking on flat ground. There's no steepness to it, just flat. Undefined. If we said we can walk uphill, we can walk downhill, we can walk on flat surface, we can't go straight up and down in the air, right? We can't fly, unfortunately. So, undefined. All vertical lines have undefined slope, and we'll show algebraically why a line will have an undefined slope momentarily. Here's some examples for you as we cover up these answers. So, before I reveal some of the answers on here, this might be a good time to pause and you can practice doing it on your own. But there's 3 examples here. I want you guys to find the slope and then figure out the lines rising, falling, horizontal, or vertical. Again, this might be a good time to pause and then play after you've done some math. So we'll pretend that you guys just paused, did some math, and now here are some of the answers to that section. Now, to review some of this, notice in my first example that the y coordinates are exactly the same. That might have been a good indication to you guys to realize that, hey, we're going to be dealing with a horizontal line, or there's going to be no change in my y coordinates. No change might lead to that 0 there. The 0 comes from 2 minus 2 is 0 in my numerator, horizontal line. Number 2 has, or example B has an example of a slope that's rising because it has a positive slope, 8/1. Positive slope means the slope is rising. In example C, we have undefined. Why do we have undefined? Well, if we notice algebraically, we end up with this value. 15 minus negative 5 is 20, and 4 minus 4 is 0. We can never have 0 as a denominator, right? That's one of the few rules of math that there's no exceptions for. You cannot have 0 in the denominator. This value, therefore, is undefined. That's why I put undefined slope, and that would imply that's a vertical line. Some notes on structure. Horizontal lines. Which value is always the same in a horizontal line, x or y? Well, in a horizontal line, the y value remains fixed. Therefore, it's going to be y equals some number. And that number specifically will be the value of the y coordinate for the points that line contains. Same thing over here for vertical. X is fixed in vertical. So it will be x equals, I should write this out, some number. And again, that number will be what is the x coordinates of the points that line contains. That will be the x value that line equals. Okay? Moving on to our last page of notes, we have some notes on the distance formula. I actually have the distance formula copied up here. You might want to copy that down as well. The distance formula is very related to the Pythagorean theorem. We use the Pythagorean theorem to figure out the value of c. Now, if I want to figure out what the value of c is, I would have to take the square root of both sides, right? I have to square root both sides to get c equals. That's kind of what we're doing over here to derive the distance formula. I'm not going to show the exact derivation of it here, but this is how we can show what the distance formula is. We're basically trying to figure out our B side, our A side, and this is our C side. Our distance formula is up here. It's D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So if I want to figure out the distance between 2 points, we're going to set up the distance formula. We're going to do x2 minus x1 squared plus y2 minus y1 squared. Simplifying from here, we get d equals the square root of 4 squared plus 3 squared. Well, 4 squared is 16 and 3 squared is 9. 16 and 9 add up to 25. Well, that means the distance of this line would be the square root of 25, which is 5, as we all know. So the distance between point A and point B is 5 units of measurement, applying the distance formula. We'll leave example B as another optional exercise for you guys to complete. The very last formula we want to review today is the midpoint formula. Think of midpoint formula as like finding the average of 2 points, right? So just to reread the midpoint formula, it's not a unit of measurement, right? It's a point on the line. And I have that up here. It's a point, it is a location. So the previous example, the distance formula, provided a unit of measurement. Slope provides a unit of measurement. Midpoint, this is going to provide us an actual coordinate pair. So an x and y value to refer to a point on the line. So when we answer this, we're not going to have just one number because, well, that wouldn't make much sense. If we're looking for a point, we should have an ordered pair as our answer. So if I want to find the midpoint, I'm basically finding the average or the middle of these two values. So in terms of my x values and my y values. So to find the middle of my x values, well, think about how you find the average of something. You add them together and divide by how many numbers are in that set. Well, there's only 2 numbers in this set. So we can do 2 plus negative 4 over 2. This is going to be my x midpoint. My y midpoint will come from similar formula. We can take 6 plus 10 divided by 2. These are two little formulas that will give me the x coordinate and the y coordinate. 2 plus negative 4 is negative 2, and negative 2 divided by 2 is negative 1. So now we know negative 1 is one value for my midpoint. Y, we do 6 plus 10 divided by 2. 6 plus 10 is 16, divided by 2 is 8. Therefore, my midpoint is the coordinate negative 1, 8. And you can almost visualize this as well. It's like, okay, well, we kind of think, well, 2, 6, negative 4, 10. If you want to use graph paper, it might help. But negative 1, 8 would be in the middle of the line connecting point A and point B. Again, I'll leave you guys exercise 2 as an optional practice for you guys to do as well. All right, good luck with the assignment today. Reach out to me if you guys have any thoughts or concerns. Stay healthy.